Hey man,
Well, like
logical.
planes can't land on a spinning ball. You agreed with me about that, right, Nate? So there we go.
No, I don't agree with that.
Planes
Okay, so
don't.
how do they land on a spinning ball with different angles of runways and different ways? Like they would have to
Because
catch up to the speed of the
because momentum is conserved. It's the same way
yeah, but
you
if
can
they only
jump
have the
in
conserved
a
momentum from
moving.
where they start.
It's the it's the
Okay,
same way you can jump in a moving plane, and you still
Yeah.
land on the same spot in the plane. You know,
okay, but you heard my response to that. I typed it out. You're on a moving
and
plane. First of all, you're in the
you
same reference
saw.
frame.
Yeah, but
Secondly,
we already had this convo in text chat, bro. You saw my responses as
I
well. I
didn't
don't know
hear in
why you.
response to that though. You said the same thing as moving
Bro,
on a
just
plane and then you jump in the air. But if you go through a gradient of tangential velocities, you no longer have the same conserved momentum as the ground below you.
But number one, you do conserve
How?
momentum because you
Yeah,
and the plane are in the same reference frame. The same way the plane
they're
and the ground
not.
are in the same reference frame. They are.
No.
Why aren't they? Why are
Because
they in different
if
reference
you were
frames?
locked in to be in the same speed as the Earth moving eastward, you would never be able to fly
Reference frames
westward or
have
south or
nothing
any
to
of that.
do with speed. But that answer doesn't explain why they're not in the same reference frames. There's nothing to
Though
do with
It
that.
it's
explains why none of this stuff does what you say an airplane does. If one airplane pulls down at two longitude and two latitude, everything should pull down there, not just the airplane above your head.
yeah.
Everything. So
If you're
what about a hot air
Well,
balloon? A hot air balloon ain't got to do it. Nothing has to do the physics.
Well, Nate, first of all, when you go up high enough, just in general, first of all, the atmosphere is not in lockstep with the Earth to begin with, right? So even if you're talking about the atmosphere helping the plane be in that reference frame, it's not in sync enough for the plane to land on uh, a perfectly stationary Earth, right? To begin with, even if it just like turned around and landed where it took off from. It's already not in sync, right? It would have to be perfect sync so that every time the plane lands, it seems as though the runway is completely stationary. But
Well,
then it
that's
goes
Because
into a
what
different
we
tangential
are
velocity.
and that's
we're
what they said.
we're in sync enough for momentum to be conserved. I don't know where this
I'm
criteria
not
is
saying I'm
coming in
not
that it
saying
has to
that
be 100% perfectly synced. You know, you
I'm
just
not
making
saying
up
that
conditions that are
no.
just in your head, Dave. Yeah.
I'm not saying that in your model that the momentum of the original spot it took off from wouldn't be conserved. That's the idea that it would be conserved. But then if it goes towards the equator, where it has to pick up eastward momentum, it didn't have that conserved momentum.
What the hell is eastward momentum, Dave? What are these?
Eastward tangential velocity, it's higher, it's 1,000 miles at the equator. And if it took off from a latitude where it only had 500 miles per hour, right, then it would have to pick up 500 by the time it got to the equator. You understand?
Okay.
So how does it do that?
It can do that easily. You can speed up and
How?
slow down and still be
Have to burn
maintaining
a lot of
momentum
fuel.
with
So you're saying
within the system.
so you're saying the pilot needs to keep track of the ground movement of the Earth so that it can be in
No,
lockstep. Well, it doesn't.
the pilot doesn't need to do that. But I'm just answering your weird question that has nothing to do
Well,
with
it's not a
flight.
weird question. It's a very very
Speeding up and
simple
slowing
question.
down, changing your velocity doesn't affect
Here, have
momentum within a system.
Mr. Stone. Yeah.
Well, that's a good point. I would say you're right. It wouldn't, for your model to work, they're saying you'd have to bank east incrementally over the period of time that you get to the equator,
You
so that you
yeah,
would pick up that
you can
tangential.
bank east. Yeah, that's
Right,
fine.
that's
But
what. But
momentum
the
is still
pilot's not
conserved.
trained to do that. The pilot's not trained to bank east to catch up to the Earth. Why not?
I'm not sure what pilots are trained. I'm not sure where it says they would need to bank east, Dave. You know, I'm not sure if what you were
You're not
saying
familiar with
is
this
true.
argument. Okay.
No, I'm not familiar with the claims you're making because I've
You're
been a
not
Okay.
part of this
familiar with
argument
the
and I've
spinning
never heard
ball,
these claims
the fact that
being
you'd
made.
have to
I'm gonna
arrange it
look into the
with
claims
that.
you are making, but at
Okay.
the end of the day, even your claims don't violate the conservation of momentum.
I'm not saying it violates the conservation of momentum. That's the point. It's not about that. It's about if it started with a conservation of momentum that's much less or even more than where it started from, it's going to have to figure out how to be in lockstep with the Earth so that when it lands on the runway, the Earth seems completely stationary. And that
But
doesn't. It's not
but it is in lockstep with the Earth, even when it's in the sky,
how.
because
It's
momentum
not.
is conserved.
The
It
atmosphere
is.
is not even in lockstep.
The atmosphere is basically in lockstep with the Earth, bro.
Okay, so you're saying
Momentum
basically.
is conserved. It's so
Okay,
close.
He's
You know,
getting
I'm
it's
not
close.
obviously
saying momentum's not
not.
conserved.
It's not a 1-to-1 match, but it's like, you know, 99.999%. You know, it's right there, Dave. It really has no effect
I'm not
on
trying to say it wouldn't be, but
momentum.
even that would make a difference. And then when it goes towards the equator, where it needs 500 miles per hour
All right,
sideways
how
velocity,
significant is the difference? Put a
I'm
number.
saying I'm not saying that 99.9% would be something that it even needs to come into this argument. I'm talking about it's not in lockstep, arguably already, and then on top of that, it would have to gain 500 miles per hour of tangential velocity eastward as it goes towards the equator.
Right, and
And
that's an
pilots aren't
Got
trained to
most
do
of the
that.
records of burning that fuel. I mean, where's all that fuel?
And if it goes west southwest towards the equator, it's never going to be able to bank east. So that ends it right there. Yeah, crickets.
Sorry, man.
Yeah,
I'm texting to somebody. Give me 1 second and
All
I'll
right, no
respond.
problem. No problem.
yeah. Are you
Yeah.
touching Google?
No,
That was a good one, Snack.
I'm,
Are you texting
I'm talking
Google?
with Branch. No, I'm talking with Branch. I'll be right there.
Branch. Oh, Branch will give you good advice. Yeah.
Google.
No, Branch and I was having a conversation with Branch before I even started talking to you.
Oh, okay. So if you got things to do with Branch, then I'm sure that takes precedence.
Yeah, I was talking to him before I started talking to you,
All right,
Dave.
yeah.
But you know, I tried my best to
I bet
entertain
it
you
was
as well.
about girls, wasn't it? About women.
No, it's not. It's not about
Yes.
women. It's a private matter. Don't worry about
Oh,
it. Could
you
you
and
could you could you
Okay, so
repeat
I'll
the
repeat
claim
it.
you made?
No, I'm just saying that if the plane
Better,
needs
don't
to
worry
pick
about
up eastward momentum, right? If it goes in through this gradient of tangential velocities, it has to know
What
how
does that
fast the
mean?
ground is moving. Well, the
What does
ground's
that
moving
mean?
faster
Eastward
at
momentum.
eastward momentum of the plane, the conserved momentum, right, that it had, it would be quote unquote almost in lockstep with the Earth when it takes off. But then it goes towards the equator where it needs 500 miles per hour more tangential velocity because it's a faster ground speed at the equator than where it took off from. Right? So the claim on your side usually is, since you're not familiar with the argument, is that you bank east incrementally over time, and they have the equation that they think would help make the plane be in this eastward momentum, and so that it could land on the runway as if it were stationary. But when it started, right, the runway that it's aiming for is going 500 miles per hour faster than where it started from. So when it gets there, it would have to treat the runway as if it's stationary, but somehow be moving with the Earth 500 miles per hour faster than where it started from. I mean, you've been in this conversation a while. I think I've gone over this.
He's just
Yeah.
waiting for the
Yeah,
standard
yeah.
response from the back channels, man. I find it funny. It's like
What?
the back channels.
What's
You
a
know,
back
the,
channel?
People messaging him, yeah.
yeah,
Man.
What's a
you
back channel?
Globers, when a certain conversation comes up, you know, you guys tag team each other in. You got the back channels going. The funny thing is,
Oh.
like on the FE side, like occasionally, like Dave, right, New Perspective, well, he might be like, hey, check out this argument that this physicist has put forth. And I'm like, cool, I'll check it out.
Right.
End of convo, right? But you
Right.
guys are like daily basis. It's kind of funny.
Okay.
Like
But
we
there's
don't
no
have
answer that he could get from anybody on this one because it doesn't.
No,
Work.
I've already given you my answers, Dave. I've told
Oh,
you
jumping on an airplane.
that momentum is not affected by a change in your velocity or your speed. So all of this stuff you're talking about, they would have to bank this way and that, and pilots aren't trained for that. I've never heard that. You're the first person saying this to me.
It's
If
very
you could
simple,
post
though, Nate.
something, if you could post something to back your claims, I would love to read it. Otherwise, I'm not going to go back and forth with you on a I said, you said type of thing. We've already done this in text.
Well, you
chat.
said you responded, but you didn't even address the very simple scenario. You realized
I
that the
did.
ground speed. No,
What
you didn't.
what was
Listen, you
what
didn't
was
hear
my
me again.
response, Dave? What was
Well,
my
you said
response?
you're trying to make it like I'm arguing that momentum wouldn't be conserved, and I'm not arguing that. Okay? I'm saying that they only have 500 miles per hour of momentum when they start, but the Earth is moving at 1,000 miles an hour at the equator. So how does it pick up the 500 miles per hour extra momentum?
But that makes no sense.
Why?
What? Because that's not how we measure momentum.
I'm not talking about momentum. I'm talking about the Earth would
But
be
you,
moving
but
faster
you
than the
said
plane.
you said 500 miles of momentum. That
Well,
makes
that's
no
the
sense because
problem.
momentum isn't
Yeah,
measured
I agree.
in distance units.
I
You know
agree.
what
That's the
you said
problem. But you have to
makes no
act, your
sense, bro.
side of the argument has to act like just banking east would give it more momentum in that direction because it has to
But
be in
why
lockstep.
not make a claim that makes sense? I can't rebut you saying that someone had a 500-mile increase in momentum because that's nonsensical to me.
No,
I
you're
can't
not understanding.
argue
I'm saying it
against a
wouldn't work.
statement that
I'm
doesn't
just
make
saying,
sense.
Nate, I'm not saying that they can pick up momentum. The momentum would start to lessen as soon as they're in the air is the point, right?
That's not
Especially if they
true.
go
But
west.
that's not true. I'm telling you,
Why?
momentum would not change because they are within a system, Dave. Do you know how momentum works? It's not just about the
What
plane,
system?
it's about the
What
system the
system?
plane is in. The
What
plane
system?
might lose. Let me finish
So
talking and
you're
I'll
saying the
explain it to
plane
you.
has no
The
resistance in
plane
its flight?
might you let me finish, bro. The plane might lose momentum, but it's losing momentum to the earth or to the atmosphere so that within the whole entire system, momentum is conserved.
That's fine. Yeah. If you want to
It
say it
will.
goes off, it's friction. Yeah, it could be transferred to friction and all that. That's fine. But I'm saying that
Oh,
that
thank
when
you.
you
So
get,
you do
yeah,
understand.
I
All right,
understand it.
cool.
You weren't
So
explaining
then,
it to me. I understood that
stop
before the
saying
argument, which
stop
proves that you're
saying
not
that
understanding what I'm
momentum
saying.
changes. Stop
I'm
saying
not.
that momentum
I'm saying
changes when the plane gets in. You are.
no, just
You
because
keep
I'm
saying
saying the
there's
momentum
a
that the plane
500
has.
mile increase in
No,
momentum. You are
listen,
Speed
inferring there's a
listen.
change
tangential
in
velocity,
momentum.
speed
Regardless
being
of what
tangent
happens to the
conservation.
momentum, it doesn't matter what happens to the momentum. If it goes off into the atmosphere, that's fine. I'm not arguing that that momentum isn't conserved. Get away from that idea. I'm saying that the plane wouldn't be in lockstep with the Earth when it gets to a higher tangential velocity. That's the problem.
It would be, Dave. I
How?
don't know.
How?
Because
How would it
momentum
be?
is conserved, bro. Oh my
Only
God.
500. It only started with 500. It needs to be moving sideways 1,000 when it gets to the equator. It needs
But that
500 miles per
doesn't
hour
change
sideways velocity.
momentum. That does not change momentum. If you
Oh my
move to
God,
the
you're not
left
getting
or
it. Never
move to
mind.
the right or
No.
speed up or slow down, momentum is still conserved,
I'm not
Dave.
saying it's not conserved.
So
That's not my argument. The
let
momentum is
It
only
is your
500. It
argument
needs to be
because
moving
you are
sideways
saying that
1,000.
the
hold on.
momentum
Oh my
changes.
God.
If momentum
You guys are
changes,
over
then
talking
it's
each other.
not
Hold on.
conserved anymore.
Hold on,
I'm
Nate. You
sorry.
guys are kind of like over talking each other and talking past each other. Dave,
Alright.
let me try to understand your
Okay.
argument here. So it's regarding the momentum, you would be talking about like a plane that is taking off at like the North Pole or the South Pole or somewhere around that region,
Or
and
even
then
halfway.
trying to
Halfway is
hold on,
500.
Dave,
Yeah.
hold on, and then that plane is trying to land at somewhere around the equator, right? So
Right.
you're saying that the momentum east to west, easterly, westerly momentum of the Earth as this plane leaves this object,
Hmm.
if it's trying to land on another portion of the object that happens to be moving faster, there would
Right.
be an issue
Exactly.
unless somehow it gained momentum
Right.
in a specific direction so that
Right.
when it approached that runway would appear to be stationary.
Right. Exactly. Nate,
Okay.
did that make sense? Nate, did that make sense?
I fully understand what your argument is, but I'm telling you that momentum doesn't change that way. All right. If you feel momentum changes that way, because you guys keep bringing up these terms, easterly and westward momentum, which
I've
makes no
ridden a lot
sense,
of planes, man.
then
I don't.
please
Again,
post something that,
I
backs what you were saying,
listen.
because
I
you just
agree with
saying
you.
it
I agree with
is
you. Momentum
nonsensical.
doesn't. Wait. I agree with you. Momentum doesn't change that way. But the problem is that it would need to be moving sideways with the Earth the same way it was when it took off, but it couldn't be because the Earth is moving faster where it's trying to land than where it took off from. So even if it conserved 500 miles per hour momentum and that didn't change, it didn't lose any of it, it would only be moving sideways with the Earth at 500 miles per hour. But the Earth is moving 1,000 miles per hour at the equator. So how does it match up then, Nate?
Yes, sir. Enjoy that silence.
I don't not do.
It needs to be
The
moving
plane,
sideways with
the
the Earth at
plane.
1,000 miles per hour, but it only had 500 miles per hour of momentum when it started. So how does it move sideways with the Earth perfectly
What do you
to
mean?
make the runway seem stationary when the Earth is moving at 1,000 miles per hour rather than the 500 miles per hour where it took off at that smaller circle?
Because it's moving with the Earth. Its momentum is still conserved. It's the same way. That's why I keep on going back to the example of you jumping in a plane. When you jump, that because if what you were saying is true, then if I jump in a plane long enough, right? If I had this magical ability to jump in a plane and stay airborne for 30 seconds, when I come back down, I shouldn't land on the same spot. That's what you were saying.
No, and I'm saying if you were able to
Yes,
jump,
because the
no,
plane
I'm
has
saying that's fine.
has turned to the left or to the
Wait,
right.
you're still not getting it,
It
Nate.
has eastward or westward
No,
momentum or whatever. So
I
I
agree
shouldn't
with
land
you.
on the
No.
I
same
agree
spot.
with you. The
But that's not
momentum
how it
doesn't
works.
change, right? The momentum doesn't change. So
So
how is it
why
going to
does
pick
it
up
change?
more momentum?
Why does it? If me jumping in a plane, the momentum doesn't change. Why does it
Oh my
change when
God.
the plane jumps off of Earth and lands back down?
Because I'm saying if the plane jumped off of Earth where the Earth was only moving 500 miles per hour, and the plane landed on a spot where the Earth was moving 1,000 miles per hour, it wouldn't have the 1,000 miles per hour lockstep momentum that it needed, as if it took off from that spot instead.
Okay, so if I was in a plane and the plane was moving at 300 miles an hour when I before I jumped, when I
Right.
got into the air, it sped up. Am I
Yeah.
not going to still land back on the same spot, Dave? Or
Dude,
am I going to land somewhere
that's a total
further
non
back
sequitur,
in the
first of
plane?
all, because you're
It's the
inside the plane.
exact same thing,
It's not.
and the plane is within the Earth's atmosphere. It's the exact same thing, Dave.
We're
No,
talking
it's
about
not.
Are you not
helicopters
like
now. Now you're
if
talking
you
about
accelerate
helicopters.
if you're driving a vehicle and you accelerate in the vehicle, are you not pushed
Mhm.
back into the seat a little bit?
Yeah, you are definitely.
So
So
if
there you go.
That's
you
not
think
the same thing as this example we're talking
if
about.
you switch 100 miles an hour, hundreds of miles an hour, I'm not talking about like 80 miles an hour or 88
Mhm.
miles an hour. I mean, it's hundreds of miles an hour. You
Mm-hmm.
you don't think that's going to matter at all? You think it's be insignificant, nil, nothing?
The gradual
Okay.
increase in velocity over that period of time. No, I mean, a plane doesn't go from, you know, they would never do that in a plane. Go from 0 to 130
Okay,
seconds.
Nate, how about
Planes
if you're
planes planes
standing
don't
on,
do that the way
let's
cars
say
do.
you're standing on top of the car, right? And somehow there's no
Mhm.
wind pushing you even, right? Let's say that was possible. You're just moving along with the car, right?
Mhm.
And then you jump up in the air and the car speeds up. Don't you think the
Mhm.
car could speed out in front of you, like underneath, and you land on the ground? Don't you think that'd be possible? Yeah,
Definitely.
right.
Yeah.
So let's say that's the scenario, because then you'd be on the
That's but
car,
that's but
and
that's
and
not
the
the
plane's in a separate
scenario.
reference frame. The problem is
No,
you don't understand that the plane is in a separate reference
no,
frame from the
it's not
Earth.
a separate reference frame.
It
Number one, the
is.
plane
It
is
has
not
It
to
in a
would
be.
separate
really.
reference.
I'll tell you
How
what.
is it?
I'll tell
How
you
is it a
what.
separate reference frame? Explain
Let's
that
not
to me.
Because
even.
it has to be able to fly over the Earth other places than it started
That
from.
doesn't
If
make
it
it
was
a
in
separate
lockstep,
reference
Okay.
yeah,
frame.
then it wouldn't be able
That
to fly
doesn't make it a
anywhere.
separate reference.
Hold up.
Yeah,
Listen, it wouldn't be able
that
to fly
doesn't
anywhere.
make
Oh my God,
that
you don't
doesn't
get
make
it.
it a separate reference frame.
But
You
like,
don't
Do
get
so
you
it,
were all
understand
the rubber.
what is a reference frame, Dave?
Yo,
dude. You don't get it.
dude. Let's go
What
with the
is a
reference
reference
frame of
frame?
Wait,
where the rubber meets
Let
the
Zach
road.
say something because you don't get it. Go ahead,
Can we go
Zach.
with the reference frame of where the rubber meets the road, where the tires hit the tarmac? Okay, in this case, right, is going to signify all the equalization of those forces that you guys are kind of quibbling about here. So
Where the boat
wouldn't
hits
we
the
have
water.
to? Well,
I
because
thought
all
we were going to
the
let Snacks talk. Go ahead, Snacks.
because the forces are going to get resolved like at the wheels and the road when it
But
lands.
what does that have to do with reference frames, Snack?
Well, I guess in one reference frame, the Earth is moving, and the other reference frame is still.
In
I'm
which
just saying.
reference frame? In which reference
I'm using
frame
it
is
as a
the
way to fucking get
is
back
the
to
Earth?
like something that's interesting to talk about, which is like that the mechanics of the landing gear would have to be very, um, they would be very important here in resolving the forces.
All right. So in
Don't you
which
agree?
reference frame?
Do you not agree
No, I
with me?
don't. I don't agree. So in which reference frame is the
All
Earth
right.
moving, and in which one is it standing still?
Do you not
Because you
know,
said
Nate?
You want to
you said
continue
that.
your
Are you
conversation
can
with new
Nate?
perspective?
Are you confused about the reference frames and you're unsure? Is that what you're asking?
No, I know how reference frames work. Because this Snack made that comment, so I'm just
So
trying to
which
get
one's
clarity from
moving?
Snack.
So which one's moving, Nate?
Which one's moving where, Nate?
You were asking about the reference frames. Did you ask
Yes,
about movement?
because Snack made the comment that one reference frame Earth is moving, and the other one it's not. So I'm asking, which reference frames is he referring to?
So you're confused? You don't understand?
I'm
about
not
reference frames?
confused. I'm just asking Snacks a question.
Can you answer
Do
your
you,
own question?
well, do you want to? Why would I answer a question I asked? Do you want to answer it, Napalm?
I'm just saying that
do you know?
I know. I just want to get clarity from Snacks, though.
What, is
It's
this like a
just
test?
It's not a test. I'm just asking questions. The same way you guys are asking me questions, I'm asking you questions.
Yeah, no,
I'm not allowed to.
I typically ask y'all questions so that I can get clarification.
And that's what I'm trying to do. I'm trying to get clarification from Snacks. What did he mean when he made that claim? If I'm not allowed to ask questions, just say so, man, and I'll stop.
No, you can ask questions. I just didn't know if you
So
were
then let
uncertain
me
to
ask
the
my
answer.
question, bro. Goddamn. But I mean, Snacks is muted anyway. I don't know if you want to answer it, Nathan.
No, I didn't.
Do you understand that the plane's in a separate reference frame? Do you understand that?
How is it? I don't agree with you. So you
I don't
need to
think
explain to me.
I don't think they
how
think
is
it
it
is,
in
Dave.
in a separate reference frame? How is
How's it in the same?
Explain it. Because from any observer on the ground or in the plane, they would have the same frame of reference. They would see that the ground and the plane are moving together. In order to go into a different reference frame, you would need to leave the system. You would need to be on the sun or the moon, because reference frames are observer dependent. It's the
So I think
observer
that's
that determines the frame of reference. And an observer can only say that something else is in a different frame of reference if that frame of reference is moving at a different velocity from the velocity that the observer is moving. So if I'm on the ground, the plane above me is moving in the same reference frame as me because it's within the same system. It's within the Earth's atmosphere. But if I'm on the sun, I can definitely say that the plane is not moving with the Earth because I'm in a totally different frame of reference and system from the plane and the Earth. You know, it's like the Coriolis effect, you know, watching the bullet go over you while you're on a merry-go-round.
No,
I think that was a very good answer, right?
No, it wasn't.
So
No.
what happens, Nate? What happens to the bullet when it's shot on the merry-go-round? Is it still in the same reference frame?
What do you mean when it's shot on the merry-go-round?
You said a
If
bullet
I
going
shot
over
it?
the merry-go-round.
Yeah, but who's shooting it? Am I shooting it? If I'm on the merry-go-round and I shoot the bullet, you know.
Does it remain in your reference frame?
No, I'll see deviation.
What is there actual physical deviation?
From my point of view, yes.
Its momentum? So if you're spinning around on a merry-go-round,
momentum is conserved, but from my point of view, I'm definitely seeing it deviate because that bullet is not moving within my frame of reference. My frame of reference it's non-inertial because I'm on a merry-go-round spinning around while the bullet is going straight. It's in an inertial frame of reference. So the forces acting on us are different, but momentum is still being conserved.
Gotcha. So when you shoot that bullet and you're a third-party observer outside of the reference frames, that bullet appears to go straight when you shoot it, right?
If I'm a third party, like I have a God's eye view looking down, yes, it'll appear to go straight.
So if I was a plane at the North Pole and I left the Earth and was traveling towards the equator, right? And you were an observer on the moon.
Yeah.
Would that plane appear to go straight as the Earth moves below it?
Yes.
Oh, okay. All right.
Then how is it in the same reference frame?
Wait, no. What do you mean? What do you mean? Yes, of course not.
What do you mean, Bacon? If I'm watching the plane go from, if I'm on the moon looking down at the Earth, right, and the North Pole is in the center, and the plane leaves the North Pole and goes to the equator, why would I see deviation, Bacon, if I'm standing on the moon?
Because the plane is going to use the atmosphere to fly. If he's going straight, he's going to get a crosswind stronger, right?
No, but let's say there's no atmosphere. It was just moving straight while the Earth beneath it was spinning.
Oh, so you're shooting a bullet
obviously,
instead of flying an airplane.
Yeah. I'm
Okay,
just trying to
yeah.
compare the airplane to a bullet. Obviously, if you factor in the atmosphere, it won't be that simple. I agree with you. But
Yeah,
I was just trying to make a
that's
one-to-one
that's the whole
comparison.
point.
Yeah. Yeah.
All right, yeah.
Does it matter the direction?
Or if you're shooting for something from the North Pole, every direction is south. You can only shoot south.
I'm talking about the observer. When the observer sees you and you shoot the thing, does it matter which way you shoot it compared to where he's looking?
Nah, not in that example. I don't think so.
Yeah, I'd say not at all.
How are you guys calling New Perspective? Is he called Dave, or did I get that wrong?
Yeah.
Yeah.
What's up, Bacon?
Right. You just so you know, you have some background noise.
Yeah, I'm trying to mute here. I'm trying to get back to the screen. Sorry.
Not a problem.
Bacon, I realized Dave's a real person. I figured that out last week. Or this past week.
What do you
Yeah, I
mean?
saw you on camera too.
Yeah. Yeah.
Yep. It's
Oh, I
nice to have
saw.
a face to
Dave has
recognize.
a face.
Oh, I saw you already. Actually, I think last year.
Fuck.
I saw you.
Eyes without a
I
face.
think
Oh, so
I haven't
y'all
sent you the
motherfuckers
video
watch
of me from like years ago when I punked them on Hollywood Boulevard. I'll have to send it to you.
Great.
Yeah,
this is why I don't go on
like
cam
more.
because you. This is why I don't go on cam because you creepy fucking Globers, man.
But yeah, so you know what I figured would be napalm. Wouldn't it be great if we could have like the angle of every runway that a plane lands on just in America to start with, right? The angle that it's at, right? And then you'd have to figure out, like, if you were a pilot flying, how fast you'd have to be moving eastward, exactly in tandem with the Earth, so that the runway, whichever angle it's at, would seem stationary, even though it's moving with the plane completely
who's
in
hot
lockstep.
mic?
Sorry, I think that was me.
It's Bacon moving his classroom desks around.
Yeah,
Yeah,
sound like
Nate, sorry, Dave. Can I ask a question?
Sure.
How do the airplanes get their speed?
Thrust.
Acceleration.
Oh, what do you mean?
By flying through the air, right? Using the air. They're riding on the air. Is that what you're trying to get at?
Well, that's one answer. I think there's.
You're
From
saying
the engines.
are you trying to lead us towards, okay, they're moving in the air, which is like the atmosphere, so it's going to be in lockstep because of the atmosphere. Is that what you're leading towards?
No, I didn't say any of that. No, I'm just saying, like, if you're getting your speed from the air, then the speed of the airplane that the pilot sees is relative to the air, right?
Absolutely.
Right. I think they can also get the speed from radars, can it? Like, aren't there some towers that the planes use to get directions and?
I don't know. Tell me this: what gauge in the cockpit? What's the gauge in the cockpit, Bacon, that tells them how fast the Earth is moving below them, like the ground speed of the Earth?
I don't think they give them the speed relative to the inertial plane. I think they give the speed relative to Earth, where the
So let me
towers
ask
are
you the same
just
question.
on the surface.
When a plane takes off at a latitude where it has 500 miles per hour of conserved momentum, right? But it's going towards the equator, right? Where it needs 500 miles per hour more tangential velocity to be in lockstep with the Earth. How does it gain that momentum, or how does it gain that sideways tangential velocity?
It's sticky air. It's sticky air and windy.
Let Bacon answer, please. The sticky air doesn't work anyway, but go ahead, Bacon. Unless he's going to say sticky air too.
Great circle route. If you
What's that?
follow a great circle route, if you follow a great circle route, are you talking about going from north to south? Is that it?
Saying like it starts at 500, like say Chicago, and it goes towards the equator, where it's going to land on a ground speed of 1,000 miles per hour, but it only has 500 miles per hour of conserved momentum. How does it do that?
They basically trying to say, Bacon, that because the Earth is moving fast at the equator, They're landing
Yeah,
on a part of the ground that's moving faster
He gets it.
underneath them.
I've been through this with
Okay.
Bacon 100 times.
yeah, yeah.
Okay.
As far as I know, they were just trying to follow a great circle route.
Right, but how does it gain momentum sideways to be in lockstep with the Earth?
Momentum sideways.
Well, if they're following a great circle, they're making a path
Yeah.
that gets faster as they get closer to the equator. Like
Why does it get
simply by
faster?
following.
Why does the path make them get faster?
Because if you look at that great circle route in the inertial plane, it's making a curve, right?
Yeah, right.
So
Would have to.
yeah. So relative to inertial plane, the plane is going to accelerate just by keeping its same ground velocity. So all it has to do is to keep the ground velocity.
Okay,
That'll
so
cause
say
it
say it didn't follow the route, right? Say it just went straight to the equator, right? Didn't follow anything, just flew there. How would it make sure that it's in lockstep with the Earth?
Oh, if it did that without following a great circle, then it wouldn't.
It wouldn't.
Wouldn't
It
be
would be 500 miles per hour, potentially 500 miles per hour difference, right?
Yeah, if it
Yeah, that'd
could
be a
follow
problem, right?
if it could follow a straight line in space instead of following a great circle,
Sure.
then yeah.
Or even just like a slightly different path. Not that I'm saying that the Great Circle Route path works. I'm not acknowledging or agreeing with that, but I'm saying just take that out of your mind. You have to make sure that the plane is landing on what seems to be a stationary Earth, right? There's never any time where the plane has to land on an Earth that's moving sideways ever, right?
Well, kind of like the Earth is like when you're landing, the Earth is your reference. Like when you're trying to land, you're trying to land on what you see, right? So
Yeah, but it's stationary relative to the plane's motions, right?
no, if
Oh, really?
if it was it's the reference frame. That's where the pilot is basing like his speed and position. It's always relative to the surface when he's landing, right?
Yeah, but you know, right, that pilots are trained in like simulators, right? And the simulators all use a stationary level Earth, right? You realize that?
Yeah, I mean,
Okay,
I'm
that's true. We all know that,
okay.
right? So if that's the case, and they're flying over a spinning ball, how are you arguing that the dynamics would be so similar that they wouldn't have to be trained to fly over a spinning ball rather than a stationary level Earth?
Oh, I can't see how it would be different. Like how it would be
You
significantly
you
different.
can't see how a spinning ball would be different than a stationary Earth when flying.
What?
No, given
Do
that, like
you
when
want to
you're
repeat that to
Straight
yourself?
to yourself.
Think about it.
no, when you're taking off,
Yeah,
when you're taking
straight
off, you're using you're referencing your speed based on the surface that is near you, right? That's below you.
No words needed.
That is not a problem. You already have the momentum necessary.
Damak,
Right?
let me do this, please. Okay,
So you already
so
have. Okay.
what now? You're
As
saying
you
that
fly,
the Earth spinning, right, at a faster speed than where it took off wouldn't make any difference. Is that what you're saying?
not significantly, no.
Demonstrate it.
Can I give an
to
example?
some degree, at least you'll agree to be different to some degree, even though it would be a lot different in my opinion. But let's just say,
Yeah.
you know, it would be different, right?
Can I
You're
give
Well,
an
it's like a
example?
less.
Go ahead,
It's like
Nathan.
Can I give an example of like trying to do this as like an individual, right? So lots of times the conservation of momentum or things like that are you're given examples of somebody on a trampoline on a truck. As the truck is traveling, you can still jump on the trampoline and you'll go up and down. It's not like you're going to fly away. You're conserving your momentum, right? Is that kind of a typical example of that?
One linear direction, right? So if the truck turned, it'd be totally different. But go ahead, yeah, that's what they use.
Yep. So I'll even use a different scenario, right? Not even the truck turning, but let's say you're jumping on that trampoline and you want to jump from that trampoline to a trampoline on another truck that just so happens to be going twice as fast as the truck that you're currently on.
Right.
Mm-hmm.
Yeah.
What would happen when your feet would hit that trampoline? Would you be able to just jump up and down the same way you would on the original truck's trampoline? or would
No, of
you?
course not. Like, if you're illustrating Dave's point, I already understand it. Like, it's not. I mean, the problem is not understanding that there's a difference in the tangential speed from where you're taking off from where you're landing. I see
Yeah.
that. That's not difficult to understand.
Well, you're saying that
I'm saying, like,
that
from the
wouldn't be any
perspective.
different than it being stationary. If it was stationary, it would be totally easy because they would just fly there and land on a stationary Earth. But you're saying that the Earth spinning 500 miles per hour faster than where it took off from would be so similar to it being stationary that it wouldn't even make a difference, and the pilots wouldn't even need to be trained to account for that. That's what you're saying.
Yeah, I'm trying to understand what would be the difference in the experience of the pilot comparing
We
both
demonstrate this.
scenarios.
Be a lot of difference because it would have to have more tangential velocity sideways, and then even if it could gain that momentum somehow, right, adding to its 500 miles per hour, so then it would be moving with the Earth at 1,000 miles per hour by the time it got there. If that were even possible, when it slowed down to land, it couldn't keep accelerating with the Earth as it's slowing down to land forwards. It would have two vectors. You'd have a sideways moving Earth and a forward moving plane, and the wheels would break off every
Well,
time.
you lost me in the end. Like,
So
okay, so
it
we
got
got
to the equator, and it only had 500. It only had the initial 500 miles per hour momentum that it had from the start. But it needs to be moving 1,000 miles an hour with the Earth. How does it do that?
Well, I thought you said assuming that it could gain momentum. Now you're saying
Well,
even assuming that it could gain
okay,
momentum,
then
we
the other
don't have the
scenario
momentum.
is if it could, even if it could, right? Even if it could speed up and keep going with the Earth somehow sideways, which it's not designed to do, even if it could do that, then when it slows down, to land, it's not going to be able to keep accelerating sideways when it's slowing down to land.
Well, if it's already already have the tangential speed, why you would have to slow down? It's like you're going from. Let me just make sure we're picturing the same stuff, right? The same scenario. So we're going from somewhere in the northern hemisphere towards the equator, right? We're going due south to the equator. So there's this eastward velocity that has to increase when you get to the equator.
Right.
Okay. The slowing down is in the south direction, not in the eastward direction, right?
They're slowing down. You're right. If it was able to somehow keep that momentum up and not have to worry about keeping the banking that it took to get to that point, right? So we would just say, let's call it velocity rather than momentum, right? Because it doesn't ever gain momentum, right? You don't think it gains momentum, do you?
You do. It does, yeah. If the velocity is increasing, then you have to gain momentum. Yeah.
Right. So but then the problem is though, if it's trying to accelerate to speed up to get to the Earth's speed, right? It has to somehow keep banking east incrementally. That's what your argument on your side usually is. They incrementally bank east, right, to somehow get it to that speed. But if banking east is what,
Dave, no, I've been trying.
Dan, do you want to? Okay, go ahead, Dan.
I've been
Go
trying.
ahead.
The lockstep in the origin point is at a different speed than the lockstep of your landing point.
Yo, can you guys unmute Zanick? So sorry, Dan. So sorry. Man.
Oh, Zanick here. Great.
So
I'll unmute him.
So your assumption is that it's not going through any speed changes during that. So the 500 miles an hour is incrementally picked up in the form of what you might call a crosswind at that point, not navigation. Because each point as you move south, the lockstep is at a different speed. So the air you're in is moving, assuming we're on a globe, assuming blah, 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 blah. The air speed of the air you moved into keeps changing, and you're not accounting for that.
No, I'm saying even if that were the case, and the airspeed were forcing you to move at the same speed as the Earth, then you would never be able to fly against the spin.
I told you they'd start bringing the wind into it.
Yeah, but the wind doesn't help them. In fact, it makes it worse because then if the wind is locking the plane into the same momentum or the same velocity, tangential velocity as the Earth. I mean, Zanick and I have had this out. I just unmuted him. But Zanick and I have had this out, and he agrees. If you got there and you were not paying attention to the ground speed, you could be totally off. It could be moving 500 miles per hour faster than the plane. If the air were the solution to this, the plane would never be able to fly against the spin, right? It would never be able to fly. Well, go ahead.
Right.
Go ahead.
Right. Yeah, I'm not sure how to explain it, but like if when the plane is about to land, if its velocity is already in the direction of the airport in a relative to the surface, then like that there would be nothing to sync with or anymore. Like everything that you have to sync with is already synced.
Yeah, if it were able to sync, right? But they never have to worry about trying to sync the plane to the Earth, right? But
Yeah,
they
if
would
they
have
did,
to if it was moving. It
okay,
would
if
have
they
to worry about that if it was moving. So.
no, if they okay, if they would just follow the path that doesn't sync with the Earth, they would be the wind would they would get eastwards wind stronger because the atmosphere is going much faster than them
Oh, but
eastwards.
okay, that doesn't help you because if the wind was forcing the plane to be in lockstep with the Earth, it would never be able to fly against the wind in the westward direction to begin with. But then also,
No,
winds go
it's
in
not
all
that it
directions.
forces
We can't rely on the wind to make sure that the plane's in lockstep with the Earth. If we
Sure,
relied
the
on the
wind
wind
isn't.
to make sure that the plane's in lockstep, that would be ridiculous. The wind would always completely force the plane to be at the same exact speed as the Earth when it
No,
needs to
the
go
wind
all over
doesn't.
the place.
Oh, 1 second. The wind doesn't forces it. It just adds some. Like if we assume zero
Okay,
wind,
sure.
there's the
Even that
atmosphere is
doesn't help you.
completely. Even that what? I didn't even say it.
Go ahead.
Like okay, so if you want to keep up with the atmosphere, there's a very small acceleration eastwards that you have to have just to sync with the surface. I think it's like 0.03
Yeah,
meters per
0.01,
second squared.
and doesn't the plane correct for that
Right.
automatically? Yeah,
Yeah.
You would hope so, but no.
Okay. Like
it does.
winds.
That would be great if
It
the
it
automatic pilot
does.
took care of it, but it doesn't.
It does. It
Okay.
does.
It does? Okay.
Maybe think of it
Can
like
I
It
a
finish?
does.
Just finish.
Doesn't. You guys are fucked.
Oh,
You guys,
Go
no
ahead.
argument.
Go ahead,
Zanuck, go
Bacon.
ahead. Zanuck coming in.
No,
It's
no, no,
going to
no,
be
no.
another showdown,
Bacon
another
wasn't done.
Coriolis showdown
Bacon
with
wasn't
Zanuck.
done.
Bacon.
Yeah, I mean, go ahead, Bacon.
Thank you. Right. If wind can give the airplane a bigger acceleration to 0.01 meters per second square, then either you're ignoring wind and you're getting also like you're getting out of your route because you don't care about wind pushing our airplane out of your route, or you're trying to follow your route, and if there's a wind that pushes your airplane in one direction, you're going to correct for that, and you won't be able to distinguish if it's an actual wind or if it's just Coriolis and you're not syncing with the atmosphere. It will be exactly the same.
sounds like a
Just
lot of
trying to follow your
Yeah.
just trying to follow your route.
Conflating Coriolis with the wind is one of the things you guys run to. It doesn't
It's
work.
not a
Of course, yeah,
You're
but
conflating the Earth turning with the wind, right?
No,
Well,
I'm not
say
complaining
you had-
anything. I'm pointing out that there you need a very small acceleration just to sync with your surface.
Otherwise, you'd
And
be fucked without that acceleration, right?
yeah, but you have bigger acceleration from just regular wind.
Right. So I'm saying that
Right.
if
So
that was the case, it doesn't matter. Saying if you were trying to gauge how the wind is moving your plane one direction or another, and it was very imperative that it's moving exactly with the Earth, there'd be a big problem because you'd have to then counteract
yeah,
some
but
winds to make sure you're still locked up with the Earth. But as you said, there's no gauge to tell you how fast the Earth is moving.
you have your route. If you're getting out of course, you just correct back to your course.
There's a magic route. That's the other thing you go to. Magic route, Coriolis
It's not a magic
winds.
route. What do you mean?
Well, you're saying just following the route makes the speed increase its tangential velocity.
say
If
you
if
had
the
say
if
you were an
the
airplane and you didn't have any control of it all. You just took off and suddenly all your controls were locked straight, and somehow was able to keep this flight path. And it happened to be a perfectly still day, and you went north. You would end up, like say you left from Central America, you'd end up, 1,000 miles to the east in
Mhm.
America,
Right.
right? So
Sure. Yeah. But if you
Yeah.
were locked up with the Earth, that would never happen, right? If you
You're
were
not
like in the same
you're not
reference
locked.
frame, that would never happen.
No, the wind. We're saying that we had it's calm. Let's say we had one of those weird days.
oh, wait, you said it was a perfectly still day. You said it was a still
wind
day.
wasn't
So no wind. No
All right.
wind.
Let Zanuck go, please. Let him do it
The wind
because
wasn't.
he'll bury the argument with himself. Go ahead.
No, I won't. It's very simple. Go north, and if you just let the plane fly, it would end up 1,000 miles in the same orientation, but 1,000 miles to the east. Now, if you finally got there, you'd be like, well, I'm flying just like I'm flying 500 miles an hour north, but why am I over New York when I should be over Chicago?
Right.
Because of Coriolis. That
Okay.
just it happened so slowly you didn't notice it because, or you're blindfolded or something. It didn't. You just didn't
Uh-huh.
show up there. Now, if you wanted
Right.
to counteract that along the way, what would you do? You would actually be turning slightly to the west, or you have a little rudder maybe the entire way to the west. So that 1.5 miles per hour per minute is all you would need to compensate. Think of you're going 500 miles an hour. You're compensating pretty easily just going north with a little bit of pilot input, very tiny bit,
But why aren't the pilots trained to do that?
because it's so small. And as was said
Oh,
earlier, hold on, as was
but
said
you'd be
earlier,
off course if they didn't.
as was
You're
said
saying they'd be
earlier,
1,000 miles off course if
all
they didn't
these
do
things
that.
that go on in the airplane are far to exceed the Coriolis force as you fly north.
Well, yeah, but you're saying you'd be so much off course if you didn't correct, right?
If there was no wind, if there was absolutely no
Right.
wind.
So regardless, even if there was wind, you're going to have to correct, right? So then if you just followed like your path straight, then you'd be off course, just like you
So
said.
now let's say we have a 1.5 miles per hour per minute crosswind the entire way.
Okay.
And we don't have Coriolis. The Earth is totally stationary.
Are winds ever that consistent?
No, but it's just
All the way there? Are you serious?
so we understand what's going on.
I mean,
So
come on,
if we
man.
did that, we would not notice that amount of wind, as we don't even in real life going. Let's say we're going west east, and we have north and south winds because those exist too. Quite often, I've been in crosswinds flying in the entire path in a
This
crosswind. Right, that same pilot input would be there, and the same effect would also be there as well, just like Coriolis. It just equals it equals a crosswind. It's all it is.
Right. So that's all it is. Okay. So the pilot doesn't have to worry about it.
Correct.
Right? It just does it on its own.
You're following a point to point. Along the way, there
Yeah.
are certain checkpoints that you're trying to line yourself up with,
Mm.
and you steer toward them. The autopilot actually steers for you toward them. But if you didn't have the autopilot on, which I don't have in a Cessna,
Yeah, you don't even need it. Yeah.
you fly to those positions.
Mm.
And
Yeah, just like it was stationary, right?
I think you guys are talking past each other. So, I mean, honestly,
I'm just agreeing with his ridiculousness at this point.
When I'm flying and I have a crosswind, I might say, why to go follow this highway? Why am I? Is this plane like out of alignment or something? Is my elevators like, or my steering wheel? Because I don't really have much force on it, but I noticed the yoke is turned. It's like this doesn't make any sense. Well, it turns out I had a crosswind the entire time. That's what you would do to follow this path. You wouldn't worry about it. You just would turn.
You said it was.
But this is what I mean by you guys are talking past each other because you're explaining all of this, Zanick, but he doesn't. He's not understanding why you're explaining that because it's to him. It just sounds like you're explaining what they already conclude the error is, which is a crosswind. But I think the whole point is that when a plane, it doesn't have an instrument to recognize Coriolis. What it has is it has instruments to tell it if it's off course, off tilt, off whatever. But it doesn't have an instrument that tells it that Coriolis is affecting it. And so that's the point: is that the errors that Coriolis would give you are already encompassed by the errors that are causing it to be off course, which includes the crosswinds. And so it's not a statement of this is good evidence for Coriolis. This is a statement that planes are the wrong place to look for evidence of Coriolis,
right?
Because it's not going to be apparent. It's going to be hidden with the other errors.
Correct. Exactly right. And so
you guys are crazy. The planes aren't a good example for Coriolis. Are you kidding me?
It's not a good example.
Right. You just said it would be off course 1,000 miles when it got there. Why would that not be a good example of Coriolis?
You forget already what I said. I go, if there was no wind whatsoever and you were able to just launch the plane off the runway, get to your cruising speed, and you couldn't touch all your controls were locked in positions to fly totally straight.
Right. Yeah, like we talked about many times before, if the plane could somehow use like the star for a reference frame and even take into account its 15-degree rotation, and it went in a straight line and it was trying to go south towards a certain destination, and it reached to that destination where at least it thought it was going to be. If it went straight towards that destination, like say New York to Florida, if it went straight to that path that it was originally on and never deviated, except for correcting for the winds that we normally have when we're flying, stayed on that straight course, then Florida would be 300 miles per hour or 300 miles off course or to the left of it, right, eastward of it, by the time it got there. So it would be the perfect tool to demonstrate the turn of the Earth if that were the plane's lockstep or dead reckoning, right? If they were able to do that dead reckoning, it'd be the perfect way of showing that the Earth actually spins. Because by the time it got to that point, then Florida wouldn't be there anymore. It'd be 300 miles per hour eastward. In fact, all of our flight destinations would be based on that idea, because if you were going to Dallas from New York, then you would go southward to get to Dallas. You wouldn't go straight across to Dallas the way the flight path shows us, right? The flight path goes straight from New York to Dallas. Right, it's a great idea. It would show the Earth spins. Why don't you guys do that?
It's a great idea. Who wants to spend the gas to be 1,000 miles off course to show Coriolis has an effect? You could do that. You could use. I like that idea. You fly north from Cuba or whatever, and you follow the North Star. You stay right. You stay. Just don't follow anything else.
No, North Star doesn't work.
Why not?
North Star doesn't. We already talked about this.
Why not?
Because it's going up to the same point. We talked about this. It's kind of a. It doesn't matter if that works or not. But we talked about this because it's actually. Because it's at the top of the supposed ball, you wouldn't necessarily get off course the way you would think, but maybe it does. Maybe we talked about that. You were trying to say North Star because that was probably
I don't think we talked about
a red herring.
I thought of it.
We talked about it.
That's exactly why it's perfect. That's why it's perfect. It's because it unlike the other stars, it relatively stays in the same spot.
Right. So if you're
right, that would be why it's perfect. But then it doesn't matter.
Whether you're in Texas,
regardless, the point is.
Hold on. Whether you're in Texas or whether you're in Kentucky, that North Star is still right there, right? So if you left from Mexico and followed the North Star and didn't look at anything else, you would end up 1,000 miles to the east.
Right. And so the plane's in a separate reference frame from the Earth, and that's the only way that'd be possible, right?
No, don't talk about reference frames because that's incorrect.
You don't want to talk about reference. Well, we had some ballers in here earlier saying that the plane's in the same reference frame. So we can at least establish that the plane's in a separate reference frame with you guys, right?
No.
You seasoned ballers.
You're in all.
No, it's not in a separate reference frame. Oh my God.
You're in all reference frames simultaneously. It's a stupid argument because
you're talking relativity now.
No, I'm talking reference frames. What a reference frame is a coordinate system for which you view motion. You are in all reference frames simultaneously. That's not the right word you're trying to say. You're saying if we're going north and we go to the North Star, follow it and not worry about what's underneath us. If we make sure we stay perfect, like you said, dead reckoning on the North Star, the Earth will rotate. We will accelerate ahead of the Earth. We will end up in New York.
But okay, sure, okay, fine. That's great. Yeah, that would be great if you could actually do that. But my point is, if you jump into like, say, you jump into the jet stream and you're going 200 miles per hour faster than the Earth is spinning, right? Then you jump out of the jet stream, right? How are you automatically in the same tangential velocity as the ground below you?
You're not. That would add or subtract.
You're not. The Earth would be spinning separately from the plane, right? Of course you're not.
Of course.
So then how are you catching up to be in the same tangential velocity when you land the plane?
You're not, remember? You're going to be.
You're not. Oh, okay. So you're landing on a moving surface.
You're not listening. If you do this, you won't know where you are. You're following North Star when you get.
I'm not talking about that example anymore. I'm saying in all other way. I'm not even talking about the North Star example anymore, Zanick.
You are so hard to talk to.
I'm not talking about the North Star. I'm just saying that the plane will be out of sync with the Earth in many different occasions, right? If it jumped into the jet stream, it's not moving in the same tangential velocity as the Earth below it. So when it jumps out of the jet stream, how is it landing on a stationary Earth?
Someone says they see the problem. You should stop for a second. So you're saying that because we're going northward and we ended up at some latitude, that suddenly we should be skidding across the surface of above the surface of the Earth laterally, like flying across toward the direction of our right wing. No, the whole idea of this Coriolis and the whole idea of what we're talking about here is that that doesn't happen. All that happens is the Earth, you accelerate ahead of the Earth, and now instead of being over Chicago, you're over New York. Going the same speed northward as you were, You made sure you were going northward, but you ended up taking a curved path. That's Coriolis. As looked at from an inertial reference frame, you would be taking a curved path. As looked at from a
Non-inertial reference frame.
from a non-inertial reference frame.
Right. So there we go. Separate reference frames.
From the non-inertial reference frame, if you viewed the path of the jet, it would be taking a curved path over across the ground.
Forget about the North Star.
Oh, look at that plane! It's turning toward New York.
Yeah. Okay.
If you're,
right.
Stop talking.
Zanick, you don't.
Absolutely batshit crazy.
You're just confirming what we agree on already.
Stop talking, please. Just let me finish the sentence. As we go north and we start traveling from the ground, it looks like we're taking this curved path because we're looking at it from a non-inertial reference frame, the rotating reference frame. If you're looking at it from the inertial reference frame, like from the sun or from out in space, the plane looks like it's going totally straight, and the Earth is, or it's going totally straight, and it is accelerating ahead of the Earth. The Earth is rotating underneath it.
Yeah.
So these two paradigms are both true. They're just viewed at from different reference frame, which is what I'm talking about when I talk about reference frames. It's point coordinate systems. And you would end up in New York, where you thought you might have been in Chicago, because you just fought north because of Coriolis. There's no other lateral speeds to rectify. There's no other skidding across the ground horizontally across the wings. You just are in a different spot. And that path you took was curved as viewed from the non-inertial frame, and straight as viewed from the inertial frame.
So a pilot that didn't know what he was doing, he's just like in the air and trying to fly somewhere, and he gets off course. He thinks he's headed in the right direction or whatever. He could be totally off course if he didn't know how fast the Earth was moving, right? He'd have to know how fast the Earth is moving below him.
You're absolutely right. So if he's
how does a pilot know that?
Total cloud cover. You can't see the ground. All his instruments are done.
Mm-hmm.
He just flies to the North Star. He thinks he's going to Chicago, and suddenly the break in the clouds. He looks down. Shit, I'm over the coast. I'm over the East Coast. I'm over New York. How did I get there? Because I didn't take Coriolis into account. I just flew straight.
There you go. Right. So why aren't the pilots trained to take that into account is the question.
Because they have radios and radar that tell them where they are at. Exactly their ground speed.
So they're trained how to make sure that they even if they weren't trained to deal with Coriolis, they have radars and ground control to help them. Is that what you're saying? Yeah. Yeah, they would have to worry about that. Yeah, they would have to worry about where they are. You would have to know where you are, and you would also have to know that your plane is going to land on a stationary runway, no matter which way it's facing, no matter what tangential velocity it's moving at. And if that varies from your original conserved momentum, you're going to have a problem when you get there, because you have to be moving sideways with the Earth, exactly in lockstep with the Earth, so it seems as though you're landing on a stationary Earth.
That's why the Earth moved under you. So you did conserve momentum.
It moved under you, so that means in a separate reference frame, right?
What reference frame are you talking about?
Talking about the Earth, the ground reference, the reference frame of the ground movement compared to the reference frame of the plane movement.
The plane movement is in both reference frames. Which one are you referring to?
Okay, sure. You could, but you don't give me that. Don't start with that. Don't start with that. I'm talking about the eastward, the tangential velocity eastward of the plane, as opposed to the tangential velocity of the ground below it. Those two reference frames. Those are the ones we're talking about. We're not talking about being in all reference frames and all of that philosophical, conjecture that you want to add to it, so it confuses people listening. Talking about the plane moving sideways, eastward, with the Earth completely in lockstep, so that when it lands, it seems as though it's landing on a completely stationary Earth, but it never had the conserved momentum to match that by the time it got to the equator from a 500 miles per hour tangential velocity it started with. That's the problem that everyone else thought there was no problem, because it's in the same reference frame. At least you're acknowledging they're separate reference frames.
But no, you're right. It gets up there, and the cloud breaks open, and you go, I'm over New York airport. We're looking right down at LaGuardia. And you're saying, well, you think you should be going 500 miles an hour faster eastward, because that's what would happen. You want to conserve momentum.
Yeah.
Right? This is the crux of the problem that you have right now.
It's not my problem. It's the pilot's problem. It's the pilot's problem, because he can't land the plane. That's the pilot's problem.
That's why. But you did conserve it, even with reference to the non-inertial reference frame, because you are now have moved from where you should be in Chicago 500 miles to the east. So now all you really have to worry about is what happens every minute. Every minute you have like a crosswind of 1.5 miles per hour. So you still can't. You still have
Well, these
to
pilots should be
rectify
trained to
this.
worry about what you're saying they should worry about, is all I'm saying.
All right, you know what's better to do? Let's look at the moon. We're on the moon.
You always go to the moon. He always goes to the moon.
You have to lose space. No
Let's
air.
look at the
No air.
moon.
Okay?
Look at the
And
moon.
we travel south. We travel southward on the moon. In this scenario, it's going zero tangent.
You're
velocity.
roboting a
Let's
little
say
bit, by
moon's
the way,
fast.
Zach.
Let's say this particular moon is a new moon, different moon. It's going 1,000 miles an hour tangential, like the Earth. No atmosphere.
Yeah.
Right? So we leave and we close our eyes and just start heading south. When we get down to the equator of the moon, we will be traveling southward, but the moon will also be traveling underneath us at 1,000 miles an hour. We will have that kind of sideways momentum, sideways disparity between the Earth, between the moon and us.
Yeah.
Because
You're roboting a little bit, Zanick, by the way.
That's what you're saying. You're saying that on the Earth that would happen. We're not going to have this 1,000 miles an hour tangential velocity because we have to conserve momentum. You're right. And if we just went south and didn't do anything else, this spacecraft that was traveling south and only going south would then be going sideways by 1,000 miles an hour. And we talked about this before.
Yeah, a couple times at least, right?
Yeah. So you're right about that. The moon. That's what would happen on the moon. If we went purely south, we would have 1,000 miles an hour tangential velocity over the moon if the moon was rotating 1,000 miles tangentially. That doesn't happen with the Earth because along the way we have something called an atmosphere and we have something called drag. And along the way, that air mass that's going to be slowing us down from going that way by 1.5 miles an hour per minute will also take some velocity, a lot of velocity out of our path along, because that's a long time. It has 20, 30, 15 hours to probably deal with that.
What I tell you, it's all about the wind. It's
Yeah,
always,
it doesn't work for him still. I don't. He's saying the magic winds, right? That magic winds help him help the plane stay.
Not winds, atmosphere. Not winds, atmosphere. Just the fact that there's atmosphere.
Atmosphere, right? Not winds, right? Atmosphere. It's moving atmosphere, right? It's moving the plane.
No,
it's acting on the plane like a wind, even though it's not a wind.
Yes, because we have a situation where along its path from North America all the way to the equator, that there's very light winds that day. Less than 5 miles an hour, all through Mexico, all through South America, wherever we go, it's all very, very light winds. But there's a 500 miles an hour difference between when we took off and the equator. And along
so you're saying these winds are perfectly predictable and consistent, so that it's always perfect in the way it makes the plane somehow. No, winds are always unpredictable, and they move in all directions. So I don't know what you're talking about.
Calm skies all the way through Mexico, through South America, all the way to the equator. It's all calm. At 5-10 miles an hour here and there, it's not going to kill anybody. No big deal. But that atmosphere along the way, because its tangential velocity is changing 1.5 miles per hour per minute, that will impart a small force on the aircraft. So by the time it gets down to Central America, it will have lost a lot of that momentum to changing the momentum of the air around it, putting force into the air molecules. So there's the issue along the way because you've bled off the speed, this tangential, this momentum, and imparted it in the atmosphere because it was going much faster than you were when you left San Francisco.
Okay, so nobody's claiming that the conserved momentum wouldn't be departed into the air through friction or none of that. It's just that you're taking off. Go back to our old scenario here, Zanick, that we've gone through for hours and hours and hours that people are probably sick of hearing. If you're starting with 500 miles per hour conserved momentum, but then you're going towards the equator, you need 500 miles per hour additional eastward momentum or eastward tangential velocity, not momentum, because you don't gain momentum. You would have to somehow speed up to the Earth to be able to land on what seems to be a stationary runway, right, Zanick?
Yes, and along the way, the plane is turning left. Yes.
But why aren't pilots trained to do that? If there's no difference, if you're having to make up 500 miles per hour, that would be something that training would be very necessary to figure out.
over 15 hours. It's very
Sure,
small.
even that. I don't care how incremental you want to make it. Even that, the pilots would know that that's what they have to do. Otherwise, they're going to be way off course by the time they get there.
Yeah,
Or even worse, they're going to have a runway that's moving sideways faster than the plane is moving sideways.
Yeah, but we went over this already, dude. That's
What are you
that's the
talking
reason
about?
why I said what I said before. I told
Okay,
you
go ahead.
that
What was your explanation?
a pilot is trained to correct
Deal
his
with wind.
course.
Right.
He's trained to correct his course. Even if there's a gremlin on the side of his plane that's dancing and fucking fucking with the engine just like in a Twilight Zone, and he's causing the plane to veer to the left, he's gonna know that he's going
Damn
off course.
gremlins.
He's not gonna have a detector that tells him there's a gremlin on there. He's gonna know he's off course and he's gonna correct his course. So it doesn't matter what causes it. It doesn't matter what causes it.
Magic course, magic winds, magic. None of it works, bro. Just because he's on course doesn't make the plane automatically in the same tangential velocity as the Earth.
What does that have to do with anything?
Just saying, just because he's on course, he's automatically going to be in lockstep with the Earth just because he's on course.
No, he's not. He's actually not in lockstep with the Earth. He's traveling in reference. Right. He's traveling in reference to the Earth. He's going at a certain velocity in reference to the Earth.
But
when he gets to the airport, he makes sure that by the time he gets off the plane, he's in lockstep with the Earth.
How does he make sure? Why wouldn't he be trained to make sure?
He looks at the ground and he makes sure that he's going at a speed.
The pilots are trained to look at the ground. The pilots are trained to look at the ground and try to move the plane sideways to be in lockstep with the Earth when they get there.
That's not necessary.
Oh, it's not, because the Earth is never moving. That's the only way that could be possible. If the Earth is moving and it has to look at the ground. Wait, how? Oh, it already taken place. Wait, go back. You lost us. What do you mean?
When he's correcting his course, anything that causes the air to be off, that includes Coriolis. So Coriolis is going to cause his velocity to be at a different velocity than the tangential. And what that will be experienced as a crosswind. It'll seem like there's a crosswind acting on the plane.
Conflation with crosswind again.
It's not a conflation with crosswind. It's how it will show up.
Listen, if the pilot had to deal with a 15 mile per hour consistent movement of the Earth below it, as well as crosswinds, there'd be a totally different situation, right? It's hard enough for a pilot to land with crosswinds when it's trying to land on a stationary runway. Now think about that if the Earth were moving 15 degrees consistently in one direction, and it had to deal with that as well.
Yeah,
not the same as a crosswind.
Zanick had already said what the acceleration is in most. It obviously changes depending on what latitude you're at, but it's never ever anything that's going to be experienced as an extreme wind. Well, it's always going to be a very subtle acceleration.
What I'm looking for,
which is going to be experienced by a very light crosswind.
What I'm looking for is someone that is on your side, that is completely not just trying to read the script that says crosswinds are so much more than a Coriolis. It doesn't even have to worry about it, or it doesn't have to just follows its course and it's automatically in lockstep with the Earth, and it can land on what seems to be a stationary Earth, or incrementally it's going to do it, or automatic pilot's going to do it. Please, just be fucking honest, man.
Yeah, I know. Here's the thing, dude. I'm not gonna get pissed off at you because you do this and you get at people, but why don't you for a second just realize, or just consider that maybe me and maybe Zanick are not being dishonest with you. We're not reading a script. We didn't know. Hold on, dude. We didn't agree with each other beforehand what we were gonna say, but we actually understand what we're talking about, and we're trying to explain it to you. So we're not reading a script. Right. Okay. Like in my head, I'm understanding how it works. I'm not being dishonest with you. And so, I know, but it's fun, but it's aggravating because you're not attempting to try and see it from what we're trying to express.
No, I understand why you think that. I don't know why you think that make it work, but it's the same argument, right? But it's never worked. It's never been adequate. It doesn't work.
He talked about looking. You start getting like a little pedantic. He says looking at the ground. No. But there's something called VOR that you look at. These are radio stations along the way, and they're all over the world. And you find out, make sure you stay on path. You're looking at your cockpit. These are the
staying on path doesn't increase your velocity sideways.
Hold on, hey, stop. The VOR system allows you to triangulate and find your way down to where you want to go. And along the way, whatever it takes to get there, you move the stick. You move the yoke, whatever you need to do to get there. And that small change in direction along the way is all you need to do to fight the Coriolis effect, which is very, very small compared to other
Well,
things.
you said they need to do it. Why do they need to do it?
Because if you didn't do it, you would, like we already started with the example that if you didn't do it, following the North Star, for example, you'd be off course by 1,000 miles.
Well, then why aren't pilots trained to do what they need to do?
Because oh my God, it's like Groundhog Day.
Yeah, see, you guys exhausted because you realize there's a contradiction. The
Kosho
pilots
said it
would be trained to
exactly
do
right.
what they need to do.
Because all they have to do is they're only trained to whatever happens. Like you said, gremlins or whatever's on the plane, crosswinds, engine out, updrafts, downdrafts, whatever. All you do is follow the course. Use the VOR inputs.
Doesn't
follow
work.
the VOR so that you stay on course to whatever your destination is along the way.
Well, if you can convince yourself that staying on course makes it go faster sideways with the Earth, but that doesn't make it make sense. Just because you're on course doesn't increase your tangential velocity sideways, moving with the Earth.
Why does it work with crosswinds? No, why does it work in reference to crosswinds then? Because if crosswinds are having an effect on your plane sideways, that same correction corrects for that. So why wouldn't that work for anything else that's causing your plane to
because pilots are trained to assume the Earth is stationary.
What does that have to do with it?
Because it would be a totally different situation if the Earth weren't stationary. And how you could think the dynamics of a stationary Earth and a not stationary Earth are the exact same and the pilots wouldn't have to be trained to deal with that is just mind-blowing that you think it works. If the Earth were moving, it'd be a totally different situation than if it weren't moving when you're flying a plane over it. I don't get why that's not obvious to you guys. Yeah, that's what I thought.
So I was talking to somebody.
Yeah, sure you were.
Actually, no, you just stumped me is what happened. You just really stumped me, and I had no idea what to say.
So why is it that a pilot's trained to treat the Earth as stationary, but the Earth is moving, and you're saying it's exactly the same, that they don't need to be treated, they don't need to be trained to fly over a non-stationary Earth? It's just the same as stationary. They don't even have to have training. Just stay on course, and that fixes it. That's really what you believe? Now you're talking to somebody again, I'm sure. Yeah, conversation, right? So funny. Zanick, you talking to somebody too?
No, I'm here. I'm just saying. I wish my dad was still alive.
So you're saying that a moving Earth is totally so much the same as a non-moving Earth, that they could be trained to fly over a non-moving Earth even though it's moving.
Yeah, because I don't know what part of
same thing.
Worry about that they don't worry about it.
You don't think there'd be a factor with the Earth moving?
No.
As opposed to not moving?
No.
No. Okay, then you too small, right? Even though it'd be a 500 miles per hour tangential difference.
It's like, hey, here's a special airplane. But by the way, this airplane will fly perfect in every condition except for when there's a 1.5 miles an hour crosswind.
Conflating it with crosswinds doesn't help you, Zanick. We already went over this.
No, it's exactly.
There's crosswinds in all directions. It doesn't correct the plane automatically.
It's the reason that we don't worry about it, because it acts
like because of crosswinds. Because there's a consistent crosswind that makes it somehow fix it, even though it doesn't fix it, and that's the reason you don't worry about it.
You know what? Fly all you want, and all your crosswinds will be directions, but this plane cannot fly if the crosswind's ever consistent for more than an hour, and you're in trouble. We got to give you special training for that. That's what you're saying. It's kind of silly.
What? No, it's not. I'm saying that if the Earth were moving, it'd be special training to land on a moving Earth.
No, it's not moving enough to worry about.
It's not moving enough. 500 miles per hour faster than where you started off from. That's a lot. That's a lot of difference, regardless of how incremental you want to say that. That correction would be that they're never trained to correct for. They're never trained to do this special correction that would make them in the same tangential velocity. But it's so minor, they could just treat it as stationary. You realize how ridiculous you sound?
Let's say you've been only trained on driving a boat on Lake Michigan, Lake Pontchartrain. You're not allowed to go in the ocean because there's currents out there. So just You have to be special training for the currents.
That is so
It doesn't
funny.
stay in the lake.
That's so
how
funny.
silly it sounds. But
That's hilarious, dude. You really think that's a good example?
It's a great example.
No, because you've gone through this scenario with me, and there's recordings of it that I could show that we could play right now, where you're talking about, okay, so if you went to the equator and you were like 500 miles per hour difference, you'd be like, oh my God, the Earth is moving 500 miles per hour faster than my plane is moving. Now I got to catch up to the Earth. And you went through all these different scenarios of saying that it would be a big problem for the pilot if he didn't make sure that he was in that same tangential velocity. How are you saying now that it's not as it's like the same thing? And I love the fact that you're thinking that the Earth moving would be the exact same thing as it not moving according to flights. Are you serious? Yes. Okay, that's what you're sticking by. Doesn't matter that the Earth's moving, even though it'd be moving 500 miles per hour faster at its destination than where it took off from.
Correct.
Same
the reason
thing.
is because that change is so infinitesimally small.
But you didn't. But you also acknowledge that if you didn't correct for it, you'd be off course. And the Earth would be moving at a different speed than the plane's moving, and all that. You've already acknowledged there'd be a lot of different things to be concerned with.
Well, there's one. You'd be off course. That's the only.
And the Earth could be moving faster than the plane is sideways.
No, that's why you're off course.
So you're saying that there'd be no way that the plane could be moving at a different tangential velocity than the Earth is moving. That would never happen?
Unless you made up that you gain momentum along.
Yeah, like if you have a bad pilot and that happens, you got to have some training to figure out how to fix that. Otherwise, you're going to crash.
What you need is keep it on. Okay, I don't want to say it again. The only thing you need.
Yeah, keep it on course, right? Keep it on course, and then pilot's not so good. He got off course. He crashed his plane because the Earth is moving faster than he is.
You're being silly. Sorry, I'm back.
Not silly. It's exactly what would happen if the Earth were moving.
That 1.5 mile an hour crosswind. And he's off course. He kept on.
This is a crosswind conflation. Crosswind conflation.
Hey, man.
Crosswinds and Earth moving are not the same thing. I'm sorry. Just because the Earth moves in relation to the plane, when the crosswind makes their plane move, doesn't mean that the Earth moving consistently 15 degrees an hour in one direction is the same thing as a crosswind. It's not the same thing.
Can we chill a little bit?
Exactly the same as a crosswind.
Yeah, can we chill a little bit? Hold on. Go ahead, Zanick. Go ahead, Zanick.
Just say,
you guys have no argument, and you're arguing that.
No, listen. Don't waste time with rhetoric, dude. Don't waste time.
Not rhetoric. I'm saying that the Earth moving and the Earth not moving are two different situations for a fucking plane. If you don't acknowledge that, then I don't know what you're talking about. You guys are hilarious.
That's great, dude. I have a question for you. And I wasn't running from you before. I really was talking. I had to take my.
Oh, sure. I'm sure you were. Yeah.
Yeah. Okay.
Well, no. Are you backing Zanick that the Earth moving and the Earth not moving?
I have a question. I have a question for you, dude. Question. Okay. We're saying that the air will be hot. It will be hidden in the crosswind. So that's my.
The air's hidden in the crosswind.
The error of the Coriolis is hidden in the error.
I've heard that many times.
It doesn't matter. It doesn't matter. It doesn't matter how many times. It doesn't matter how many times. It doesn't matter how many times you've heard it, dude. It doesn't matter how many times you've heard it. That's not my question. That's not my question, dude.
Okay.
You know what? Today's my birthday, man. Okay. Today's my fucking birthday. Listen to me, dude. No, dude. I just want you to give me one gift. The only gift I want for you is to shut the fuck up. Shut the fuck up when I'm talking, dude. Right?
Go ahead, man.
Okay, because I have a question for you.
You're gonna try to make it like back on me with a question that you think's a gotcha that I can't answer. So then you feel like, okay, I didn't get got myself.
Dude, there's not gonna be any need to guess if you wait 5 fucking seconds.
Okay? Go ahead.
All right. Okay. Yeah. The question is, as I said, my stance is that the error in Coriolis will be
hidden in the winds.
In the air.
Hidden in the winds. I'm just hidden in the winds.
That's good, man. See, I asked you not to talk, so you decided to fucking sing instead.
Okay? It's hilarious, dude. Come on.
Listen,
you have to see the humor in this. Hidden in the wind.
It's hard for me to see the humor in this when I'm livid.
Okay?
You're not livid. I'm a little bit livid, dude. But regardless, here's the question. Let's stay on track. Stay on track. Here's the question. It's hidden in the crosswinds. Okay, that's my stance. So the question is,
that's a pretty good stance.
The question is, how, in your mind, you have a plane. I just got it for you. It's a normal plane. It's got all the sensors on it.
Sounds like it's my planes
have. Yeah, it's your birthday, and I got you a plane. It's got all the sensors on it. And I'm claiming that Coriolis is affecting the plane, and actually in this universe, Coriolis is certainly affecting the plane. So, at the plane I just bought you, how are you going to realize this? Like, what part of the plane are you going to sense? What's going to show up to you that tells you that Coriolis is acting on this plane, and how are you going to make a distinction between what it's doing to the plane versus what something else that's taking you off course is doing to the plane?
Okay, so if I understand your scenario correctly, you're saying that if in a totally different universe somehow the Coriolis is a problem for the plane, right? How would the pilot then worry about the Coriolis where it actually is a problem rather than not being a problem,
No.
as if the Earth were stationary
That's not
but
the
actually
question.
moving?
It's not the question. The question is, in this universe where Coriolis affects the plane the way that we claim it does, how are you as a pilot going to realize that and make a distinction between Coriolis taking you off course or anything else taking you off course? What is going to be the indication that tells you that that's Coriolis doing it versus anything else?
Right. So how is it not hidden in the winds is what you're asking.
I'm asking you, how are you expecting us to realize it? Because you're laughing nonstop when we're spending. I heard Zanick 30 minutes ago say the same things to you.
Okay.
I'm asking you, how would a pilot realize that it's Coriolis and not?
What's making me laugh is that you're saying that the pilot's trained. You're acknowledging the pilot's trained to treat the Earth as stationary, but the Earth is moving, and the pilot does the same thing. It doesn't matter. But then there's all these other things about like being off course and all these other things that you should have to worry about. So yeah, your question is, how would the pilot know if it's the wind making the plane off course or if it's the Coriolis making the plane off course? And how do you make that distinction?
Specifically, how would he know that it's Coriolis versus anything else, including the wind, but anything that's taking him off course? How is he? Right. How is he to know that it's Coriolis doing it and not something different? What's the indication?
The Coriolis. Okay, first of all, Coriolis force, right, is what you're talking about.
This is your time, man. This is your time to
answer. Yeah, but okay, but you're calling Coriolis as if this thing that like acts on the plane, right? Coriolis is a difference between the movement of the ground and the trajectory of the object in the air. Because this object in the air is in a separate reference frame from the ground, and if the plane were to act like a bullet and just go straight as it could, it would be off course, because the Coriolis effect would be that it is no, actually the Coriolis effect is just the way it looks from space or wherever you want to say, the third reference frame where you're looking at the course, right? That would be the Coriolis effect, right? It just makes it seem as though it's going in a curved path even though it's going in a straight path. That's not what we're talking about. We're talking about the displacement that would occur if the plane were traveling completely dead reckoning to south, and it ended up off course from where it was, where it ended up trying to get to, like we're talking about with Florida from New York, right? So being off course is you're trying to make it as if the course itself is going to correct the plane into this new sideways tangential velocity. Problem is that you've got a gradient of tangential velocities that's flying, that the plane is flying over, right? And it needs to treat the Earth as stationary, but it only has the conserved momentum from its original takeoff spot. Let's say it's 500 miles per hour. Now, we're supposed to assume that the plane is moving eastward tangentially at 500 miles per hour, even though there's no gauge for the pilot to know that it's moving sideways 500 miles per hour, yet forward at 400 miles per hour, right? That's something that we just treat as a given, right? It's just in the background of this, like, okay, we were moving with the Earth when we took off, so we're just going to keep moving sideways with the Earth, and we're going to assume that 500 miles per hour tangential velocity never goes away. It's conserved. But hold on, wait. When we get to the equator, we need to be moving at 1,000 miles per hour sideways with the eastward momentum or the velocity of the Earth. But we only have 500 miles conserved momentum from where we took off. So how are we gonna now land on what seems to be a completely stationary runway, which it always is, no matter which way the runway is facing, no matter what tangential velocity it's supposedly going, no matter what direction the plane flies, it's always going to not ever have to worry about landing on anything but what seems to be a stationary Earth, which would be impossible if the Earth were actually moving, because it doesn't have that sideways momentum that it had when it went from 500 miles per hour. It wouldn't have the same velocity sideways when it gets to the equator. So I would say that'd be one way to tell. You get to the equator and you don't have that sideways momentum, and you see that the Earth is actually moving below you, that'd be the way to know that it's not the crosswinds that made the Earth move, because that doesn't make the Earth move anyway. The planes moving with crosswinds is totally different than the Earth moving below it. There's no conflation there on my part. You want to say that the movement of the Earth and the amount of distance off course it would be so little compared to these crosswinds that go in every direction that it doesn't even have to worry about it. It just follows its course and it gets there. And somehow it seems like a stationary runway, even though it doesn't have the same tangential velocity as the plane started with. So how does it make up that velocity, especially if it goes west-southwest? How does it bank east to get any eastward momentum, Kosho? If it's trying to bank east to get more eastward momentum, but it's only flying west and south towards the equator, how does it bank east to get more eastward momentum?
I'll tell you exactly.
Not that pilots are trained to do that anyway, which they would have to be if it were actually moving.
I'll tell you exactly how it's done, because it's fairly simple, and it's only been said to you 18 times in the past few minutes.
Really? Go ahead. How's it do it? Stays on course?
Yeah. What happens is the pilot tries to go. The pilot tries to go to where he's going. Okay, and he hopes everything's going hunky dory, and it is, until something happens, and he doesn't know what it is. But he's not worried about what it is because he's already prepared for it. He knows he's off course. He corrects his course. Whatever's just happened to him, it's causing him to appear to be going laterally, horizontally, like sideways at some extra velocity that wasn't there before. He doesn't have any indication that it's the wind because he forgot his wind sensor. Okay, so it could be the wind, might not be. It's not as strong as the wind, not even close, but it's still happening. And so what does he do? He just corrects his course. Easy.
And then he's automatically in the same tangential velocity as the Earth.
He's not in the same tangential velocity to begin. He's flying in a plane.
Yeah, and he would have to pick up tangential velocity as it goes towards the equator, eastward, because it's 500 miles per hour faster eastward than it was when it started off.
Yeah, if let's pretend like it's on a plane.
So how does it pick up momentum? Staying on course doesn't do it. Crosswinds don't do it.
It's the same mechanics as a plane, but let's just make it simpler so we can picture what's happening and say that it's on the ground, okay? And the track that it's taking,
that's non sequitur.
It's drawn on the ground in paint, okay?
Same reference frame.
This plane that's on the ground, that's drawn in paint, it's following that yellow line. But it's going in the same direction.
Why do you have to put it on the ground?
The yellow line is pointed because I don't know how else to make you understand this, dude.
No, because I don't understand it if it's on the ground, because planes don't fly on the ground. They fly in the air in a separate reference frame, and there would be a 500 mile per hour different speed. They would have to go eastward 500 miles per hour faster than where it started from.
Okay, I have magical paint. I have magical paint that I can paint in the sky, and it stays there. Okay, because I can't use the ground. So there's a line drawn from where he is to where he's trying to go. All he's doing is following that line. If something happens in the middle of his flight, a giant pushes his plane, some wind blows it, Coriolis happens, who knows what happens. But he's following that yellow line, going the same direction, but he's moving further away from the line. So he's noticing that he's moving sideways at some velocity. Something caused him to do that. What is he going to do? He's going to correct his trajectory so that he's back on that path. That's all he does.
Okay, so how does it gain eastward momentum?
He flies back towards that line.
But how does the line make him gain eastward momentum?
His line doesn't do that. His hands do that. His hands move the plane.
How does he do that?
It moves. It toggles the fucking.
So he has to make sure that he's moving 500 miles per hour faster by the time he gets to the equator.
All he's worried about doing is following that path that he was meant to be following. That's all he's doing.
But I'm saying that what if he doesn't follow that path, then he's going to be fucked by the time he gets there. And if the path doesn't make him go faster eastward. Just following the path doesn't make him go faster eastward.
The path doesn't do that. It's him purposely trying to be on that path is what does that. If he's not caught up with it, he purposely lines himself up.
So him staying on the path makes him move eastward faster.
That's the whole purpose of what he's doing. He's trying to make sure he's on that path.
Staying on the path makes him move eastward faster. Is that what you're saying?
Dude, he's on a plane that he has controls over. He has an engine.
Right.
He's moving.
He's got to pick up 500 miles per hour eastward.
Yeah, the plane helps him do that.
Amount.
Yeah, the engine helps him do that.
The engine helps him.
The engine helps him. He guides the plane so that it lines up to his path, and he stays
All
on
right.
it. If
Well,
he
if
goes
he-
off that path, he corrects that. It's that
Right, but the
simple. Like,
path-
I don't know how.
Staying on the path gives him more eastward momentum, and that's ridiculous.
Yeah,